Hi, welcome back to Professor Ray. Today's lessons on section 6.1, System of Equations in Two Variables. Now this should all be reviewed for this section. We're just going to cover the three methods, the three first methods you learned, which is graphing, substitution, elimination. A system of equations is just two or more equations considered simultaneously. Okay, so that's the key. So the idea is what's going to be a solution to both. So I just want to remind you a few things. So a graph is a picture of the solution set. So when I ask you to graph something, I'm actually asking you to draw a picture of all the solutions to that equation or inequality, whatever the case is. Okay, so let's go over how we're going to do system of equations. So to solve a system of equations, a system of two equations and two variables graphically, our first step is we're going to graph each equation on the same set of axes. Okay, and then once you've graphed each line on graph each equation, what you're looking for is the solution that works for both of them, so that would be the intersection. Okay, let's look at an example. Solve the system x plus y equals 2 and y equals 2x minus 1. So our first steps, we're going to graph both lines. Okay, so let's take the x plus y equals 2. You can do the x and y intercepts. You can put it in slope-intercept form, so let me do it that way. I'm going to subtract the x from both sides. Y-intercept is 0, 2, and the slope is negative 1 over positive 1. So I'm going to start at 0, 2, go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Now, when you're doing this by hand, you should do a whole bunch of points, as many as you can fit, because we want to make sure our graph is accurate. So I can also do positive 1 over left 1. So up 1 to the right 1, left 1, up 1 to the left 1. Okay, and then you draw the line through that. Now again, I want to emphasize this. All the points on this line are solutions to the equation x plus y equals 2. Alright, now let's graph y equals 2x minus 1, where y-intercept is 0, negative 1, and the slope is positive 2 over positive 1. So we got a negative 1, up 2 to the right 1, you see they intersect there, up 2 to the right 1, up 2 to the right 1, draw the line through it. Now again, all the equations on this line are solutions to y equals 2x minus 1. And then the intersection is the solution to the system. Okay, that's the point that's true for both equations. Okay, so our solution to the system is the point 1, 1. Now you can write it in set notation. You can just write 1, 1 like that. Box it, either way. Okay, so again, the solution set for the system is just the single point where they intersect, which is the point 1, 1. Okay, so for two linear equations and two variables, there's actually three possible outcomes. First possibility is like the one we just did, where you get two lines that intersect at some point. So that has one solution. Okay, the next possibility is we get two lines that don't intersect, which would be parallel lines. So if we get line 1, we'll call that line 1. Line 2, and they don't intersect. So that would be no solution. possibility is both lines are actually the same line. So you get line 1 and line 2 are actually the same line. And then in this case, all the points on the line are solutions to the system because they're, if it's true for one, it's going to be true for the other one. So all the points on the line are solutions. Okay, so some terminology you may hear me talk about a consistent system. Consistent system has at least one solution. So A would be a consistent system. And so would C, because if it has an infinite number of solutions, it has at least one. So that one's consistent. And an inconsistent system has no solution. So the parallel lines, that would be an inconsistent system. Okay, so for two variables, if one equation can be obtained by multiplying both sides of the other equation by a constant, just by a number, so if you multiply everything by 5 and then you get the same equations, then we call the equations dependent. Okay, so basically that's going to give you the same line. Okay, and we're talking about two variables only. Otherwise, so if they're not the same line, they're independent. Okay, so looking at example A, B, and C above, A is independent. B is independent because they're two different lines. And C would be dependent. Let's try another example. So let's solve graphically 3x minus 2y equals 12 and y equals 3/2 x plus 1. Okay, so for the first equation, let's do the x and y intercept technique just to practice it. So if x intercept, we're looking for x, y is 0. So you plug in 0, and the y term goes away, so 3x equals 12. So 3 times what equals 12? So that would be 4. And then for the y-intercept, you do it the other way around. You put 0 for x, so the x term goes away, because anything times 0 is 0. And then you get negative 2y equals 12. So negative 2 times what is 12? That would be negative 6. So I plot those 2 points, 4, 0, and 0, negative 6. Draw my line through it. That's my line 1. And I'm going to do the next one. Y equals 3/2 x plus 1. Slope, or y-intercept, is 0, 1. Plot it. The slope is positive 3 over positive 2, so up 3 over 2. I can go negative 3, negative 2 also. And then you draw the line through that. And what you see is these lines are parallel. And if we were to convert the first equation to slope-intercept form, you'll see that they actually have the same slope and they have different y-intercepts, so they are parallel. Y equals 3/2 x plus 1. So these are parallel lines, so that tells us there's no intersection point, so that tells us no solution. And if they ask, is this system consistent or inconsistent? The system is inconsistent. If they ask, is the lines dependent or independent? They're independent. on to the substitution method. Now, so we're going to solve this one by the substitution method. Our first step is you're going to solve either equation for either x or y. Okay, so you have basically four choices. You can solve equation 1 for x, equation 1 for y, equation 2 for x, equation 2 for y. So any one of those four. I like to label, that's equation 1, equation 2. So for step 1, I'm going to take equation 2 and I'm going to solve it for y. So I got 4x plus y equals 3. Subtract 4x. So you get minus 4x on the other side, plus 3. Okay, so that's step 1. Now step 2, we're going to take that result and plug it into the other equation. So that's really important to use the other equation. Because the idea is we got to take all the information from both equations and boil it down into one equation with one variable. So for step 2, I'm going to take this result, y equals negative 4x plus 3, and I'm going to substitute in the negative 4x plus 3 for y into the other equation. So I've got to take equation 1, which is 2x minus y equals 2, and I'm going to take the y out and I'm going to plug in the negative 4x plus 3. So we got 2x minus negative 4x plus 3 equals 2. Distribute the minus sign. So 2x plus 4x minus 3 equals 2. Oh, this is step 3, by the way, that I'm starting. So step 3 is you're going to solve the resulting equation from step 2. Okay, so we're going to combine like terms, and it's just basically basic algebra 1 here. So add 3 to both sides. 2 plus 3 is 5. Divide by 6, and you get x equals 5 6. Okay, so step 4 is we're going to take the result of step 3, which in this case was x equals 5 6, and you're going to substitute that into the result of step 1. So the result of step 1 was y equals negative 4x plus 3, and I'm going to take the 5 6 and plug it in for x. Now, alternately, you could plug it into the original equation 1 or original equation 2, doesn't matter. And then you just solve for the remaining variable. So we're going to take y equals negative 4, take the 5 6, put it in for x, punch that in our calculators, and get an answer. Okay, so just we get negative 26, which reduces to 10/3, negative 10/3, and then plus 3, which is 9/3. So that gives me negative 1/3. If you want to do it by hand, or you can do it by a calculator. Either way. And this is not really a step, but I like to write it out. Okay, so remember, when we're solving system of equations, you get, with two variables, you get one of the three conclusions. Either it's a single point, because where they intersect, it's no solution, because they're parallel lines, or an infinite number of solutions, because it's the same line. So in this case, it's a point, so you're going to write your answer as a point. So I would like to emphasize that, to, keep in mind what's happening here. We got a system of equations with two variables, so the solutions are points, x and a y. So ordered pair. Okay, let's review how to solve using the elimination method. Now, some books refer to this as the addition method, and some books refer to it as the elimination/addition method. So, depending on how you've seen this before. So, our first step is we're going to add the equations together. Or multiples of the equations together to eliminate one variable. See, that's why it's called the elimination method. Our goal is we got to eliminate a variable. So a lot of times I get students ask me, well, where'd you get those numbers when I multiply? And the real question is, first you got to remember, our goal is to eliminate a variable. So you pick either x or y. So if I choose to eliminate x, so you look at 3x and negative 2x, you want the LCD. What's the LCD or LCM of 3x and negative 2x? We can ignore the sign for a minute. Which is 6x, right? So what's the smallest number that both of them divide evenly into? So our goal then is now to eliminate x, I need one of them to be 6x and the other one to be negative 6x. So now you ask yourself, okay, 3x times what is 6x? And then hopefully you say, okay, so 3x times 2 equals 6x. So I'm going to take equation 1 and times it by 2 so I can get a 6x here. So this is my notation. So I call the equation 1, put the circle around it, and I'm multiplying the whole equation 1 times 2 so I can get that 6x. But then golden rule, you got to do it through the whole equation. So 6x plus 8y equals negative 4. And then you ask yourself, okay, now I want to get negative 6x. So 3x times what equals negative 6x? Oh no, it's negative 2x times what equals negative 6x. So that would be 3. So I'm going to take equation 2 and times it by 3. And again, you got to multiply the whole equation by 3. Okay, so we can't break any of our algebra rules here. And then I'm going to add these equations together, and you'll notice 6x minus 6x is 0, so that goes away. And then we get 23y equals negative 1. So that's step 1. So now step 2, we're going to solve the resulting equation from step 1. So that was step 1. And then now step 2, we're going to solve this equation. So you just divide. You get the y by itself. So this is step 2. And then from here, the rest of it is just like we did the substitution method. Now we're going to take the y, plug it into equation 1 or 2 to solve for the remaining variable, the x. So step 3, I'm going to take the result from step 2, which is y equals negative 1/23, and I'm going to plug it into equation 1 or 2. So let's plug it in equation 1. Negative 2x plus 5y equals 1. Oh, that's equation 2. Okay, let's take equation 2, and I'm going to plug negative 1/23 in for y. Okay, so we got negative 2x minus 5/23 equals 1. I'm going to add 5/23 to both sides. If you want, you can clear the fraction. You know, you can still do that kind of stuff. I don't mind working with fractions, to be honest. So 1 is 23rd. 1 equals 23 over 23. Plus 5/23, so it's 28 over 23. And then I'm going to divide by negative 2. So remember, dividing by -2 is multiplying by the reciprocal, -1/2. So 28 over 23 times -1/2. I can cross cancel, and I get 14/23 negative. Okay. So then, of course, the last step, really not a step, but I just like to emphasize it. You write your answer as a point. So that's 14/23, comma, -1. It's -14/23, comma, -1/23. Oh, and by the way, how do you check it? Well, you just plug it into both equations. And that's to make both equations true. So let's see, 3 times -14/23 plus 4 -1/23. Does that equal -2? Now what I do, it's not hard to check fractions. Just the top is multiply, the bottom is divide. So with a calculator, I would go 3 times -14 divided by 23 plus 4 times -1 divided by 23, hit equals, and the screen says -2, so -2 equals -2. Check. Then I can check the other equation, -2 times -14 over 23 plus 5 times -1 over 23. Does that equal -2? Or no, it should be +1. All right, so I punch it in my calculator, -2 times -14 divided by 23 plus 5 times -1 divided by 23, hit equals, and you get 1. Check. So I can see that I did it right. Now, alternate step 3, instead of doing step 3, is you could do step 1 and 2, repeat step 1 and 2, but eliminate the other variable. So if you have fractions like this and you want to avoid it, instead of plugging it in there, you can do step 1 and 2 again, but just eliminate the other variable. All right. So that, well, let me do one more problem, and then we'll conclude this lesson. All right, so here's an example. The owner of a daily grind coffee shop mixes French roast coffee worth $9 per pound with Kenyan coffee worth $7.50 per pound. In order to get 10 pounds of a mixture worth $8.40 per pound, how much of each type of coffee must be used? So with these type of mixture problems, I always make a chart, and what I do is on the top line I put the equation that relates whatever's happening. So in this case, we want coffee that's worth $9 per pound with coffee that's worth $7.50 pounds. So the idea is up here, if I were to just buy the French roast, for instance, and took a bag of this up to the register, what would they charge you at the register? Well, there's two things they need to know. One, how much coffee did you get? How many pounds? And what's the price per pound for that type of coffee? And then you would take those two numbers and do up with it to get a price. And hopefully you're saying, oh, you're going to multiply it. So if I'm going to take the number of pounds times the price per pound, and you can interchange these columns, it doesn't matter because it's multiplying. And I'm going to multiply those two numbers, and that's going to give me my total cost for that bag. Total cost, total price, however you want to say this. So what I do is I make my chart, and on the side I put the things that I'm mixing. Okay. Let me make the boxes bigger because in a line. Alright, so I have Kenyan or French roast. I'm going to mix it with Kenyan. And then I want my mixture. So So on the side I put the things that I'm mixing. So the item A, item B, and then the mixture on the bottom. Number of pounds, we don't know, so we can say that's X. We know it's $9 per pound. So that bag, that portion of the bag is going to cost $9 X, or just 9X. And then Kenyan, we don't know, we call that Y. And a lot of times I would use, instead of using X and Y, I'll use F for French roast and K for Kenyan. I already wrote it, so we'll leave it. And then Kenyan $7.50 per pound. So that's $7.50 Y for the price. Now, I want to get a mixture that's total 10 pounds. That's worth $8.40 per pound. So I can multiply across, and that's $84. Now just note, if I use two variables, you need to use two equations to solve it. So I need to come up with two equations from this chart. And generally, you know, for these mixture problems, you get a total mix, right? You have X pounds of French plus Y pounds of Kenyan to give you a total of 10 pounds. So like I might do 5 and 5, or 8 and 2, 7 and 3, so on. And then I need another equation. The other equation you're generally going to get in the final column where the total cost is. So if inside this bag I have, say, 2 pounds of the Kenyan, that'd be $18. And then 8 pounds of the, 2 pounds of the French, that'd be $18. And 8 pounds of the Kenyan, that'd be whatever 8 times 750 is, $60, I guess. And then you get the total between those two, and you add them up. So that was a long way of saying you're going to add. Remember, to get the total down at the bottom, this 84, you have to add the two pieces. So we get $9 X plus 750 Y equals 84. I'm going to call that equation 1 and equation 2. Now typically when I do this, I always take the smaller one in equation 2, the 750, and I'm going to eliminate Y. So I'm going to take equation 1, eliminate Y, and multiply by negative 750. So I get negative 750X, 7.50, negative 7.50Y equals negative $75. In equation 2, you can leave it alone. You got $9 X plus 750 Y equals $84. The Y's eliminate, and I get $1.50 X equals 84 minus 75 is $9. Now I'm going to solve that, divide by 150. So X equals, looks like $6. Oh wait, X is not dollars, pounds. 6 pounds. Now make sure you answer the question, because we're using system equations as a tool to answer the word problem. So we need to answer the question, which is how much of each type of coffee should be used. He should use, or needs to mix, how much of each type of coffee was used. Okay, so he used 6 pounds of French roast. Oh, I haven't finished solving it, because now I need to know Kenyan. So if we go back to equation 1, X plus Y equals 10. Yeah, up here it's not $10, it was just 10. X plus Y equals 10. If X is 6, that leaves us 4 for Y. So you just solve that. Use 6 pounds of French roast Sorry about that. And 4 pounds of the Kenyan coffee for his mixture. Okay, so that concludes the lesson for 6.1. Go to my math lab, complete your exercise there, and I'll see you next time.